Mumble. Okay. They're all the same function. They're all x squares. They're all some version of x squared with just a little change, a little twist to it. You have to be able to pick out what's going on because we're graphing this. Not by hand on your test, it's multiple choice, but you have to be able to identify what's happening based on the numbers. What do all the little changes do to the original parent function? The parent function is just a pure 1 times x to the second, nothing added or subtracted to the x, nothing added or subtracted afterwards, nothing in front except a positive 1. What we're building on is this idea. F of x is equal to something a times a parentheses x minus, inside the parentheses, x minus some number h to the second power, which is y to the square, all these are squared. And then afterwards, we're adding some other number k. It is exactly like when we started with lines, y equals mx plus b. M tells us something about what the line is going to do, and B tells us where the line is going to go. Y-intercept and the slope. This tells us where to put the line. This tells us how to draw the line. Is it rising? Is it falling? How steep to make it? Every piece of the equation tells us something. A, H, and K tells us something about the graph. Every single function you will ever graph, A, H, and K tells us something about the graph. Tomorrow in the trig class, we're going to start graphing this. Y is equal to A sine B parentheses x minus A plus a K. H and K tell the sine function, cosine, tangent, secant, cosecant, cotangent. They tell that graph to do exactly what your H and K are going to tell it to do. Now, because this is a different kind of function, it's periodic, which means it just keeps on going and repeating and repeating. It's a wave. This A operates a little bit differently, but not too differently. And the B changes how long it takes to complete one period. The B has a purpose. Their job is to identify what does A do, what does B do, what does H do, what does K do. Your job is to identify what is the A, what is the H, what is the K. Bottom line. If you can figure those things out and what they do, all your graphing from here on out is going to be a piece of cake. But you have to start there. It's about the A, the H, the K. So, substitution is important because you are going to have to also know how to plug stuff into equations. So we have -1. So f of -1 is going to be parentheses, -1 is going to get squared, but we get a +1. So when -1 goes in, we get +1. And then cut to 0. So when 0 goes in, 0 squared, we get 0. 0, 0. F of 1. So when 1 goes in and we square it, you see I'm using parentheses for the part. 1 squared is still 1. So when x equals 1, the y is a 1 for the pair. And then when we plug in 2, 2 squared is 4. So when 2 goes in, we get 4. -2 went in, the y value is a 4. right here. -1 went in, the y value was +1. 0 went in, and we got the origin, 0, 0. And then when we plugged in 1, it stopped decreasing, and then it started to increase. It started to increase, and we bounced back up to 1, 1. And then when 2 went in, we're up here at 4. There's symmetry about this graph. There's symmetry about the y-axis. The left side and the right side have symmetry. When I'm 2 units to the left of the origin, the y values are 4. And when I'm 2 units to the right of the origin, the y values are 4. 4, when we're 2 to the left, we're at a 4. 2 to the right, we're at a 4. If we go 3 to the left, we'll be up here to 9. If I go 3 to the right, we'd be up here to 9. There's symmetry. And that's a parabola. That's the name of the shape. It is a conic section. We'll get to conic section later. Which means I can slice a cone in a certain way, and that will always give me a parabolic shape. Okay. X squared always are going to graph and make that shape. That's the parent curve. That is the parent curve for quadratics. When you have a power of 2, the biggest power, the biggest exponent is a 2 quadratic, is a parabolic shape. That is the parent curve from the very first week of school. And then we do that to it. Put a negative in front of the square. Now, when we put a negative in front of the square, is the negative being squared? Is this negative in a parentheses? So it ain't being squared. Only being squared is x. So when I showed you the example, plugged in -2, there's this negative in front of the x squared. So there's this negative, and then I substituted -2. So there's this negative in front of -2 squared. So there's this negative, -2 squared is +4. So -4. G of -1 is going to be a negative, and then a parentheses, I squared the -1. So G of -1, have this negative. This -1 squared. -1 times -1 is +1. So when -1 goes in, okay, -1 comes out. And then we plug in 0. So there's a negative in front of my 0 squared. So G of 0, negative, 0 squared is just 0. What is -0? It's still 0. So when 0 goes in, I still get 0. G of +1. This negative is still in front. So there's a negative, and then I square the +1. So G of +1 is negative. 1 squared is 1. So when you plug in +1, you get -1. When you plug in 2, there's a negative in front. then we square the two. So g of positive 2 is this negative in front, 2 squared is 4. So t goes in, we get 4. So we plot these points at negative 2, we get negative 4. So a negative 2 goes in, we're down here at negative 4. And then when we plugged in negative 1, we're at negative 1. Plug in 0, we're at 0, 0, 0. Right there, the order. So it's increasing from left to right, the graph is increasing. It's increasing as we go to the right. And then once we get to 0, the next point over, we plug in 1, we go back down, we're at negative 1. It comes back down again. At negative 1. And then when we plug in 2, we're going back down even further, we're at negative 4. What happened to this picture? You put a negative in front of your function. If I put a negative in front of this function, then it reflects that function, it reflects it across the x-axis. Always, no matter what you're graphing, whether it's an absolute value, a square root, a sine curve. If we grab, and I'm just, you don't need to know this, but I'm just giving you an idea. If we grab y equals simple parent function for sine x does this. It starts at 0, 0, and it goes up, and it goes back down, it goes back up. And this is 0, that's 1 pi, that's 2 pi. And it keeps on going, and it goes left and right forever. It's a wave. But if I graph negative sine x, I put a negative in front of it. It's just going to flip it upside down. Anything that was positive is now going to be a negative because it's going to make it a negative with that negative in front. So this would flip down here. And if I have a negative number, a negative in front of the negative, that would flip it up here. So instead of going up and then down, it's going to go down and then up. Okay. It just reflects it. Anything above, that's if it's above the x-axis, it's a positive number. If I put a negative in front of a positive, it's now below because it's now a negative number. Yeah. Hello? Over there? Hello? Yes?
Oh, I mean, it's not famous.
Were you trying to call?
I was.
I'm never in the office, you know that.
Oh, I'm sorry.
There's anytime you put a negative in front of a function, reflection across the x-axis. So here's what we're building for today's lecture is y equals, we start with just f of x. You're going to have an a in front. If a is less than 0, negative, it's going to reflect it. In other words, it's going to flip it across the x-axis. That's all. If it's a positive, it's your parent function, right side up. If it's a negative, flip it upside down. Okay. That's what we're building on. Okay. Here. Just as a quick demonstration. That's the first function. That's x squared. Okay. Y equals x squared. So right here, when x equals 1, we're at 1, 1. So here's -1, +1, and up here is -2, +4. One, +2, +4. Now, if I try to graph negative x squared on the same graph. Here. I would on. And try to graph them both at the same time. It's graphing the other one, but nothing showed up. How come? My window's not, I need below the x-axis. My window is only showing above the x-axis. We already demonstrated that if I put a negative in front of the x squared, it's going to be below it. I'm going to do a zoom fit. So there's above, and then the negative x squared was down below. It took the original function and flipped it. There's that -1, +1. There's that +1, +1. -2, 4 got flipped down here to -2, -4. -1, 1 got flipped down below, got flipped down here to -1, -1. 0, 0 did not change because if you change the sign of 0, opposite of 0 is still 0. So it's not changing. This y value of 1 gets flipped down here. So that's at 1, -1. That 2, +4 is flipping down here to 2, -4. All the y's change sign. Okay, everybody flipped. Want to make this so far. The original f of x, parent function x squared, -1, 1, -2, 4. Oops. I put them back. -2, +1. -1, 1. 0, 1, 1. Key events. Negative exponent. -2, -4. The y values are just opposites of them. -1, -1. 0, 0. +1, -1. +2, -4. And then h values. So we plug in -2. In the parentheses. -2, take away 2, and then we square. So h of -2 is equal to what? -1. Substitute, then simplify. So -4, and then we're going to square it. What's -4 squared? +16. So when -2 goes in, we get 16. One. So we substitute -1 in for x. -1 minus 2. And then we're going to square it. So h of -1 is equal to -3 squared. And -3 squared is +9. So when -1 goes in, we get 9. 0. So now 0 goes in, we get 0 minus 2. Squared. So h of 0 is just -2 squared. And that's +4. So now when we plug in 0, we get 4 instead of 0, 0. Here's what happened before. Once we got -2, -1, 0, then the numbers started repeating. 4, 1, 0, 1, 4. -4, -1, 0, -1, -4. The y's repeated. Right now we're at 16, 9, 4, which one? 1 minus 2 squared. So h of 1 is equal to -1 squared, which is +1. So when 1 goes in, we get 1. And it doesn't repeat. Something different's going on. And it should be something different because, look, we're doing something different to the function, x minus 2. And then h2. So 2 minus 2 squared. So that's 0 squared. So when we plug in 2, we get 0. When we plug in -2, we're way up here at 16. We're way up here at 16. Now just hit. We plug in -1, we're now here at 9. We plug in 0, we're here at 4. We plug in 1, we're here at 1. Plug in 2, we're now there. And we don't have a full parabola. I plugged in the same numbers and I don't have a complete picture. In fact, relatively speaking, this was everything I needed to see, and this was just the flip of it. I had a left side, symmetry, and right side. That's just one side. So where's the other side? How about I only have one side?
That one's better than that one, go right on. Not this tip. Sorry.
Because
Um.
well, you can't just say I don't know. What would be your reason?
And just at the top, it should be, there should be one of, opposite side, like on the plan, right?
So you mean bottom here? Or over here?
No,
Or here?
no.
So left, right, down,
You go down, shouldn't it?
should go down. Well, the parent curve is always like this. So it's either going to go up or it's going to go down. We're not going to go sideways. Sideways is later. You have to switch the x and the y to go sideways. It would have to be y squared instead of x squared. So it can't go sideways yet. What changed between what we had, just plain old x squared, to where we are now? What's going on? What happened? Subtracting 2.
It's gonna offset it.
So it's going to offset it. When I plugged in, let's just say when I plugged in 0, when I plug in 0, I get 0 squared. But when I actually plug 0 in, what is getting squared?
-2.
-2. I'm getting the answer for -2 squared. So when x is 0, I'm squaring -2. I'm squaring the negative. That's why I'm getting a 4. That's why it's up here. Normally, when I square -2, I get +4. Get +4. But now when I substitute -2 into the function, before I square it, I have to take away 2 more. X minus 2. I have to take away 2 more. So here's the x that I'm plugging in. I'm plugging in -2. Before I square it, I got to take away 2 more. So now I'm going to square -4. So its y value is 16. So what happens is the graph is shifting. Okay? The graph is going to shift left or right based upon, and when you think about it, I'm messing with the x coordinates. I'm changing the value of x before I square it. Which means it's going to shift the graph left and right. You change the x's, you're going to move the graph left and right. You change the y's, you're going to slide the graph up and down. Now we see x minus 2. Which way did the graph, you think, which way did it shift? Did it shift to the left or to the right? It went to the right. Look what happens if you plug in 3. H of 3 would be 3 minus 2 squared, which is 1 squared. So when 3 goes in, we get 1. Now it starts to come on back up. When you plug in 5, we get 5 minus 2. Sorry, 4. Got ahead of myself. 4. So 4 minus 2 squared is just 2 squared. So when 4 goes in, we get 4. So this graph was shifted 2 units that way because of the x minus 2. Everything was shifted 2 to the right. Now wait a minute, x minus 2, wouldn't it go to the left? No. To the opposite direction. It's a built-in negative. The negative is always going to be there. Okay? This h, x minus h, that is the formula, that is the equation. H has got a built-in negative. So when you take out h, you take out the opposite side. If I see x plus 3, h is negative 3. We're all that. What's that?
The name of it. The name of it.
Horizontal shift. It's a horizontal shift. If I see minus 5, it's going to go to the right side. Think about it. You know who the favorite number is to always try to plug in? You know who we really, really like? 0. This point right there where it changes from decreasing to increasing, it's got a special name. That's called the vertex of the graph. That's the vertex. Okay? 0. What value, x minus 2, what value would you have to plug in for x to get us back to 0? Positive 2 or negative 2? Positive, so it would have to shift to the right. Positive 2. It's a horizontal shift, 2 to the right.
We could use that formula by, so shifting it the other way, you would just make it x plus h.
No, you never change you never change. It's always x minus.
X minus.
But if you saw x plus, like right here, you see x plus 3,
Yeah.
h is negative 3.
Okay.
So this graph is being shifted to the left 3 units.
Okay.
Okay. So
Okay, yeah. So no matter what, it's always okay.
So that one on. I grabbed it. Okay, there it is. There it is, but I don't have enough to show. I'm not seeing the whole thing. What it is showing me, though, is this vertex is now there. But if I want to see enough of the picture, then I'm going to go and change my window from -2 to +4. So I can get to see the whole thing. And I'll do a zoom fit. So change my window from -2 +4. So I have enough to see the whole thing. And I'll do a zoom fit. So here's the first parent graph. There's the upside down -x². And then here's the shift to the right. It's this same graph, but everybody's been shifted to the right 2 units. Yes, if it's inside with your X, it's a horizontal shift. What if it's after the function? So we take the square and then we add or subtract a number to it. So like right here, x² and then -4. For the sake of time, take a look at these ordered pairs. It's the original function, x². That's these guys. So j of x, x² -4, 2, 1, 0, 1, and 2. When we plug in x, nothing's going to change. We're not adding or subtracting anything. We're just going to square, which means we're going to get these y coordinates. When I plug in -2, I'll get a 4. -1, get a 1. 0, I'll get a 0. 1, get a 1. 2, I'll get a 4. But then after I square these x's, you take 4 away. After I square these x's, right here, I'm going to subtract 4. Okay? So after I square -2, I get 4. And then I take away 4. What's 4 minus 4? 0. After I square -1, I get 1. So the old graph is at -1, 1, and then take away 4. What's 1 minus 4? -3. When I plug in 0, I get 0. 0 squared is 0. And then I take away 4. What's 0 minus 4? 0 minus 4. -4. When I plug in 1, I get 1. 1 squared is 1. And then I take away 4. What's 1 minus 4? -3. And when I plug in 2, I get 2 squared, which is 4. And then I take away 4. It's this answer, x², because that's x². And then you subtract 4 from all of the original x² answers. That's a vertical shift. To get rid of the goal is to not have to plug in anything. That is absolutely the entire goal. Is I don't want to plug in anything. To identify the A and the H and the K, and you're just going to grab between them. And I wrote down then go back to -2, 2. So here's the original parent function. There's the -2, 4. There's the -1, 1. 0, 0. 1, 1. Positive 2, positive 4. And then the new graph, you take these old y coordinates and you're going to subtract 4. That's a vertical shift. It's going to shift the graph down 4 units. So we took that y value and shifted it down, straight down to negative 2, 0. And shifted that down 4 units. This was at 1. It took that point and shifted it down to here, 4 units down, okay, in that direction. So now we're at still negative 1 for x, but it's at negative 3. It was at 1, it's now at negative 3. 1 minus 4, we're now at negative 3. This was at 0, 0. This got shifted down, straight down to negative 4. Everybody went straight down 4 units. That's now positive 1, negative 3. And that's now straight down at 2, 0.
Might be a silly question, but what would be like the application of this? Like, why would you use that?
Nothing is just going to be a nice parent curve. It's all about being able to manipulate equations to identify how things are changed based on A, H, and K. So these are the building blocks to get us there. How does simply changing 1 or 2 numbers shift it, move it, flip it? If you're going into nursing, you got to understand what the EKG graphs are telling you. You got to understand how the sine, all the curves and how amplitude of heartbeats, frequency of heartbeats, all of that stuff, what it means. I hope, because that's what all those things that machines measure are based on mathematical formulas. Okay, it interprets the data, puts it into mathematical equations, so it can show up as a graph or a on-screen graphic. But it always boils down to it, so you can predict what might happen later on.
Okay, that's
Once we come up with an equation, we can now plug in any value of x and predict what might happen later on.
okay.
Or regress and predict what would have happened before. Okay. But we have to learn how things get moved, things get shifted, things get flipped. And the whole A, H, and K idea works for any kind of graphing problem, for any kind of function, no matter what. A changes it, flips it up, or from right side up to upside down. It also would make it wider or narrower, depending upon, is it bigger than 1 or less than 1? We're not going to worry about it right now. H moves it left to right, do the opposite sign. I see a +3, we're going left. I see a -2, we're going right. And then K, you see how K has a plus in front of it? For K, you keep the sign. H is the horizontal shift. K is the vertical shift. The most important point to locate, no matter what, is the vertex. The most important point you have to locate and plot first is the vertex of a parabola, the vertex of an absolute value, which is that sharp corner. On a square root, it's that initial point or that starting point because it doesn't have a vertex. And you know what those points are? This is HK. If you can look at the equation and pick, it's like going down the police precinct and looking at a police lineup and picking out a lineup, what's A, what's H, what's K, and picking out H and K, you know what the vertex is. This is HK. The vertex right here, that's HK. This equation was H of X. This was X squared minus 4. What's the A in front of this X squared? Well, if it was 0, then we wouldn't have any X squared. It's a one. Is one positive or negative? So we know it's gonna go up. Do you see a parentheses?
No.
So inside with the X, H would have to be A. Do you see any number added or subtracted from the X in here? Oh, so H would have to be A. 0. And then, so here's what I'm after. I gave my police line up and down quickly. So A is a 1 times X squared, so A is a 1. Inside the parentheses is where H lives. Since nothing is in, there's no parentheses in the first place. The only number inside there would be 0. X minus 0 squared is X squared. And then K is always after the function happened, after the square. So what is right here? What K is being added and subtracted? K is A. And -4. You keep the sign on K because it's a plus, you keep the sign. H is the opposite sign. K, you keep the sign. So the vertex is at 0, negative, 0, -4. It was right there. So what's this A right here? -1. So it's going to be drawn upside down. What's the H inside? There's a parenthesis. What's the H in there? Opposite sign. I see +3, so H is -3. What's the K after the square? 2. So the vertex, which is our H, is going to be at -3, 2. So if I was going to graph this, 3 to the left, up 2, it's going to be right here, and I'm going to graph it upside down. That quick, that short, that simple. Especially as a multiple choice. I just got to find one that's in the second quadrant like that. HK. At 10 o'clock, this is a big.